Hi guys, welcome to another cool film. Right guys, so in this cool film, we want to continue with what we started in episode 1 with regards to software application containers. Episode 1, we looked at traditional deployment without containers. We discussed some of the benefits of the containers in regards to having a self-isolated environment, in regards to making application portable in regards to cutting off a lot of stress that comes with traditional deployment, especially when you're not sure of the target environment's parameters and um, its environment configurations and the chaos that can come with going with traditional deployment. So we don't want to go with that approach moving forward because things are changing, human beings are evolving the technology is also evolving, so we want to go with what's more modern and what's more current. So in this go we want to look at some of the chaoses a little bit again before we even put our application in containers. So once we are able to achieve that, we'll call it a wrap on this go film. And then before we even go ahead, just for us to know that this is not a Docker class, this is not a Docker tutorials. This is a tutorial based on a problem and you finding the solution with the technology. So as we stand as co-films, we do not give tutorials. We actually find solutions to problems and use technology to solve problems. So that's what we do here at co-films. Alright, so guys, let's just go straight into the co-film. So let's start with software application containers. Has our application been containerized or has it been Dockerized? Alright, so what we do in our IDE currently, we have some number of applications that have been listed over here. So we want to go ahead and start with some of the flaws of the traditional deployment or the chaoses that we can actually visibly see. Then we appreciate why Docker is promising us of self-isolated environment and we promising that of our application being portable. So we have an application here. It's a simple RESTful API, which you make a call to an endpoint and it gives you a response. Nothing fancy over here. Very simple logic. But the problem comes with when the developer is done and he has to do a deployment. So how am I going to deploy this? Because I know that I've written a solution. There was a business problem, and then I had the solution to the business problem. Then I said I'm ready for deployment. Now I want to go and deploy my solution. The deployment is also another issue. So first of all, solving the problem was the issue. The next thing is deployment is also another issue. So how long is our customer going to wait for his final solution before he actually continues with whatever goals and objectives that he has for his own organization, business, um, motivations, you name it. So we have to find a solution to that, and the solution is with Docker. But before we do that, we have to look at some of the problems that we're going to experience and get straight into the Docker. So as it stands now, we've written one of the state-of-the-art solutions that solves a lot of problems in the world, but we are we are now going to deploy it. So let's just simply do that. So we have a Java application. This Java application is using Java 8. So it's using Java 8 libraries to work. And we are not going to deploy it as Java 8, even though it's using Java 8 libraries. We are going to use Maven to compile this and package it. And the Maven version we are using is going to be with Java 17. And the reason is that the Maven build we are using or the Spring Boot application we are using, it turns out that of late Spring Boot starts supporting from Java 17, and that's what's happening now. So Maven 2, because Maven has a plugin with regards to um, Spring Boot, it also builds start compiling or supports compilation from Java 17. So that's why you have to go with Java 17. to compile. So we are going to compile with Java 17, but I'm using a Java 8 JDK, which is not a big problem because I'm just using it to write the code. But when I'm compiling and when I'm going to do the deployment, that's where there's going to be an issue. So we'll go ahead and build this first. Let's compile it. Sorry, yeah, get bash. Yeah, so we're going to use Maven to compile our project, and then we'll run our application on two environments. We run our application on the first environment we want to look at is the app server. So we'll go ahead and say Maven compile. So Maven clean, sorry, let's clean the project. Then Maven compile. And Maven package. Okay, so it turns out that Maven is doing its work. When Maven is done, we'll pick the jar file and go and do the deployment. So we've successfully done our deployment with Maven, and we're happy to know that Maven has been able to package it for us using a Java 17 JDK or Java 17 runtime environment. So let's go ahead and deploy this class, this jar file that Maven has produced for us using Java 17. So Maven turned our source code into a jar folder, and that jar file that jar file is what is been compiled, or it has been turned from source code into a jar file that only Java 17 and above can understand. So if we go ahead and we just locate our jar file, we realize that this is our jar file here. So go ahead and let's use FileZilla to transfer our file to the server and we deploy our server. So we are going to do an FTP transfer with FileZilla. So connect to a remote server, then we do our deployment on that server. So we'll start some of our virtual machines here. Let's call our virtual machines and we'll do the deployment on our app server. There's a codefilm that will be coming out very shortly in regards to Java as a platform and Maven. Something to do with JDKs, JREs, JVMs, and build systems. Because it turns out that we are using Java 8 to work, but we are compiling or sending the class files, everything in through a Java 17 compiler. And that too, that too raises a lot of eyebrows because it's like, how is that possible? I thought Maven was only supporting um Java 17. So how is it possible that I'm using Java 8 to work, but I'm compiling with Java 17 compiler? And we'll look at that in another codefilm. Yeah, so let's see if our server is up. Our server is not starting. Yep, so let's go ahead and let's start seeing some of the issues that arise from using different environments, though we are still working within our technology or within our framework or within our programming language. So this is the server that are inside. We are currently inside our app server. And in this app server, we want to find out what is the Java runtime environment here. The Java runtime environment here is 17, Java 17. So as we've said, we look at the OpenJDK or the JDKs, GRAs, JVMs, the build system in another codefilm, because there's something interesting in regards to this as we look at Docker, or as we look at why applications really have to be in containers. moving forward. So Java 17 is understood on this server, which means that if you are bringing any application that is not within this release or within these editions or within these versions, our application is not going to work. So it has to fall within that. If it's more than that, that's if we bring Java 23 on this server, the server is not going to understand it. So, but if it's Java 8 on this server, is going to be compatible because 17's JDKs or APIs have been able to be upgraded or have been able to be updated. That should be the right word. Sorry, has been able to be updated all the way to 17. So downwardly or backwardly, I can be compatible. So that's the backward compatibility in regards to your Java application. Right. So now that we found out what our Java version is in, now that we've also been able to find our IP address, let's go ahead and deploy the jar on this server. So I'll log in and I'll just go ahead with the host 192.168.223.94 app user 2024.22. Let's do a quick connect and then let's deploy our file. Okay, so we are currently in our server. So let's deploy our application.jar here. We just logged in and just copy the file. So it's ready. So let's confirm that it's showing. Sorry. Let's confirm that it's showing here. So just do it. Let's store. So we can see application.jar. That's 1.1 jar, which shows that it has been copied successfully. Alright, so what we want to do is that we want to start our application on the Java 17 environment here. So it's calling the wrong file. Alright, so let's check again. Alright, so we're starting application. And we can see that the application is actually starting. And the final response we are seeing in the log is started application in 5.95 seconds, which means the application has successfully started. So we can actually call this API and then we'll have a response. This is fantastic. We don't have an issue with this. So our solution that we developed for that client or for that customer or for that particular problem has been fixed, has been deployed, and we are all enjoying the service, which is nice. Now let's take the scenario whereby we don't have we have a server that is a legacy server. That server runs only legacy applications. So I go ahead, I go into join a technology group. Then it turns out that I've been given a problem. And the problem is a business critical problem or it's an issue, it's a very big issue. Then I'm able to write the source code, I'm able to get it up, fix the problem, then it's time for deployment. And then, and then it comes as a surprise to me that, oh, we have a legacy server, so your application is going to run on the legacy server. Then I'm hit with the shock that I may not even be sure, but I may find out like you not even think about it, but you just go and do your deployment. Then you find out that when you do the deployment on the server, it's not working. So now the question is, what's the solution to this? So that's what we want to look at right now. So we're going to take this application that we've developed and compiled with Java 17. And we're going to deploy it on a legacy server. The legacy server is running live applications that customers are interacting with, businesses are interacting with, clients are interacting with. you name the the end user that you are targeting, they are all interacting with it. And because of one application that has been developed or one solution that has been developed that solves a problem, are we going to cause all other applications to be shut down because there's a solution that's not working? So let's make room for that particular solution. Everybody give space or make room so that this application can work. Are we going to do that? No, we don't want to do that. So let's just actually look at what happens when we look at the chaos that can arise from such a thing. So we'll actually start our legacy server because our legacy server is running legacy applications. Then we look at the disruption that comes around it. As simple as it seems or as theoretical as it looks like, if you really picture such a thing in a big organization or a corporate organization as to business demands and expectations and delivery and time being so precious, you realize that it's a very big problem. But personally, if you are doing your personal development, you will not see it as a problem. But in the real world or in real time, it's a big problem. Yeah, so it has to end, and it ends with you working with you using modern technology like Docker. So going to log into our legacy server now. All right, so let's confirm. Okay, since our password is a little bit time issue our password. Let's get the right password. Oh, let's do it again. Alright, so we're finally in. Right, so this is our legacy server. So we have our apps running, and then these apps are working. Everybody's interacting with it, as we've explained. So we just go ahead and check our Java version here and realize that our Java version here is Java 8. So this is what the legacy server is running. So we are going to move our application here, or our solution, not just an application, our solution, the project that we've been working on. We are going to actually deploy it and let it become live. So we are going to connect FileZilla to this server or do an FTP to this server. And once we do that, we look at the chaos. So connect to this server with our IP address. So we'll go with 192.168.223.94. The reason the IP address is the same is because it's dynamic and we have connected our virtual machines in a certain mode. There's actually a cool film to that, IP addresses for virtual machines. So we're going to connect to our server, talk in a particular port, then we transfer our file. And so let's move our file. Right, so our file is on the server. Let's go run our files. We're actually done with the deployment. So it's now time for us to actually run our application. So we'll go ahead and start our application. So Java minus jar. Then here is the issue we get. It tells us that it's not supported. In other words, the solution you are bringing onto the target environment will not work. So we have to find a solution to this. So this is just one use case of why we have to put our application in Docker in a container. So let's go ahead and deploy on our app server because our app server supports Java 17. And you see the discomfort. Just imagine I running through two servers because one supports, one does not support. So if there was just Docker, it doesn't Docker just makes our life easier. So let's go into this server too as well. Then let's go ahead and deploy our solution. Okay. Another interesting fact that we also want to look at after this will be the JDK JVM bit of it. And there's going to be a codefilm on that JDK JVM and build systems because there's also something interesting about that because you have a Java application which is supposed to run everywhere, which does build based on Linux or Mac, but because of some underlying reasons, it doesn't work on a particular runtime environment, Java runtime environment. So we log into our app server to the document. Right, so what we do is that we check our Java version. It's Java 17. Alright, good. So let's just put the application here and let's go. So let's find our IP address. So 192.168.223.94. Right. Let's kill this connection. I don't want to have any old sessions and tunnels. So do the deployment here. 216.223.94. I'm suffering from some slight better. Okay. So we are connecting. Application is up. Then let's do the deployment here. So we're going to move our application to the server. Or we're just going to do our deployment. So application then. So look for software. So I transferred our file. So it's transferred. So let's check here. Apps. So you can see software at the bottom. Alright, so we'll just go ahead and start this. And we are having an exception because it says that there's an exception is null. And that's because there's an environment variable dependency as we explained. So how do we fix this? So let's define the environment variable build version. And let's set it to one of the build versions, 1.0. And this time around, let's run the application again. You see, so it tells you that the license running is home. So which means that once the environment variables get tampered with, the application is going to also not function as it's supposed to, as expected. So we can't allow this to happen because there will be disruptions all over. Just imagine you're a business, you have a solution that is working out there in the real world, in real time. Then a user enters your system or a script or a virus, then it messes your environment variables and all your applications get disrupted or there's chaos all over. It's not the best. So we have to fix this. So this is just the second use case with regards to Docker promising us of or containerization promising us of a self-isolated unit or a self-isolated environment or a snapshot of the operating system, which helps you to run an application in its own operating system space or boundaries or namespace. All right, so what we'll do now is that we want to look at the third case. The third use case is very interesting. And I think I still have the application here. Yeah, so the third use case is whereby I'm running a normal Java application, but during the application's installation phase, the application is able to tell me that it's not going to work on this Java runtime environment, this particular Java runtime environment. And the reason is because of its own advantages or reasons such as performance. So it turns out that when we start the application, it says that OpenJDK JVM is not supported on this platform. So the JVM on the runtime environment that this server is promising us of is not working. It's not going to support its installation. All because it sends or it has confirmed that this JVM is not what is going to run its bytecode on, and it doesn't want it, so you can't force it. So it's a use case that tells you that if it was just a Docker container for this, or if this application has been containerized, it was not even going to know what the target environment parameters or environments are. It's just going to run the application or start the application and it's going to work. But because of this such issues, it says it's not going to work. So there's a strong use case for us to start Dockerizing application. So what we want to do is that we're now going to Dockerize our application, especially the application that was deployed on the legacy server. We are going to deploy it on the legacy server, but this time with Docker in use. So we take the same Java 17 version or compiled application in Java 17. Then we're going to deploy the application. I'm going to deploy the application on the legacy server. So we'll still stick to compiling it with Maven, which supports Java 17 compiler. But we are not going to deploy it on a Java 17 environment. We are going to deploy it on the legacy server. And that's this time around, the deployment we are going to do is going to be with the help of Docker. So let's go ahead and see how we are going to put our application in a container. So to do that, first things first is that we'll create a Docker file inside our application. So say new file. We'll call it Dockerfile. Then we'll tell it that. So we're going to write some instructions here as to how to get containerized. So as we stress, this is not a Docker class. So we're going to tell what we're just trying to say is that let's use or let's just use an OS virtualized instance that supports Java 17. And the reason is that, yeah, we'll compile it with Java 17, but the operating system instance should support Java 17, and it shouldn't care about the target environment. So the target environment's worry will be the worry of Docker, but the same source code that worked in Java 17 should also work in the operating system that has been virtualized with Java 17. So it shouldn't be different. So we're going to do with some instructions here that go and get me a JDK version of 17. Let's get Java 17, but let's get a particular image operating system support. So we are just entering commands to put our application in a container. So it just says go and check for Java 17 and give me a particular Java 17 version. So what we are doing here is that Docker has an architecture it works around. So there's a repository or there's a hub that all Docker images will be saved to. So once any image that you want to work with, you go to the repository and get the base image. You can even get your own images too as well. Then you get ready for your containerization. So if I go online and look for OpenJDK Docker app, it will list a number of images or a number of base images or operating system images that has Java support. So there are a number of them over here. So you can choose whatever that you want to do your deployment. So if I go with 17, if I type 17, it will list some number of tags. So maybe 17 slim, I think 17 slim. Yeah, it's not searching the way I want to search. Right, so let's just scroll down. 17 slim. So we have 17 slim. So this OpenJDK 17 slim, this one tag you can use. So you will go ahead and just use this operating system virtualized instance for Java 17. And it tells you everything about it. So we're just going to use this image. So that's what we are saying over here. So use the base image of Java 17. And let's just know who this Dockerfile belongs to. So just you set up ownership. So say maintainer is codefilm PLC. And then what we do that we want to now move the jar file into the OS or VOS. Let's call it virtualized OS. So how do we do that? We'll just copy where the jar file is located and the name of the jar file when we deploy it. So the name of the jar file is application.1.jar. Then we call it application.1.1.jar. So what does this basically means is that you go and find the application.1.1 jar and copy it to the operating system's file system. So just as we have it here, that we have a file system here, we have a directory that is going to work for us. So the directory we're working through here is the home directory of the user, which is home app user. So in that same way, we are just telling the operating system to get the Docker to move the file that is seen locally and send it into the home part of the operating system that we are trying to work within. Then let's start our application in the container or in the viewers. Say entry point Java. This is the same way we start in Java application. Alright, so we are ready to get our application running in containers. So what we are doing is that we are putting our application in containers. So once we are able to generate the container and run it, we are good to go. So to do that, we'll build an image. So we just have an image, and then with that image, the container runs from the image. So we need an image for this. So we are going to build an image for that. So we'll build an image with Docker build Docker building the directory -t, then just a way of um, creating an image. So we'll just go ahead and create an image for this. Then we'll call this our Dockerized application. Dockerized application. Then we can even add version, and we add a tag to it. So the tag we'll call this alpha. Right, so what we're just trying to say that just build an image. Once you have the image, let's go and deploy it. So let's just do that. So we are building the image. So there's an issue. It says no such file. Alright, so sorry, we are building it in software. So let's change our directory to application. See the backwards. Sorry. Then application. So let's take the command again. Alright. So that's fantastic. We are building an image. So once the image is built, we will send our image to our repository. That we've created our repository on Docker, which will house our own images so that anybody anywhere can go ahead and get our image if that's what we want, or we can keep it privately. So we go ahead, we get our image, then we do our deployment. So our image is ready. Let's go ahead and even check on our server. That's on our Docker Hub instance and see if we can find our own image. So we go to Tools, let's see under this section, run to our repository. Okay, let's check Docker Hub here. Yeah, so go to this is our Docker Hub instance. So this is I on Docker Hub, my personal repository where I can save my images. So we're going to push our image here. So let's push our image. So we'll say Docker push. Then we'll go with codefilms PLC and Dockerized application. And alpha. So we are pushing our image to our repository. That's what we're just trying to do. Good. So we are sending our image to the cloud. Once that one is done, we can get our image accessible anywhere and run our application because we've set it to be a public repository. We're done shortly, then we test our application. Right, so when this is done, we'll be back. Right, so we have been able to push our image to the repository. So let's go ahead and confirm our repository if it's even active. That's fantastic. So our image is now on our repository. So what we're going to do is that we are now going to deploy our solution onto the legacy server. Originally, the legacy server doesn't support the Java 17 um, application, and we've seen that. So we are now going to go to our legacy server, which has support for Docker, and we are going to run our solution on the legacy server. So we are not actually touching our legacy server's environment because live applications are on it. But what we are doing is that we are actually creating a continuity. We are actually having a way of preventing a disruption or chaos with with a strategy that will make all applications that do not meet the legacy server's target environment properties still work and still deploy. So that developers do not have to go back and rewrite solutions, and business has now to be aware of um, technology issues and the rippling effect it has on um, customers and also clients and the business revenue as a whole. Yeah, so let's go ahead and log into our server. Alright, so we're in our app server. So in our app server, I'm going to pull our image. So we say Docker pull, and then you get our image. Docker pull codefilms PLC container. Let's confirm. Dockerized application rather. So Dockerized application 1.1. Then alpha. Alright, so we're going to pull our image on this legacy server and we are going to start our application. So it's been able to pull. The reason our legacy server is able to do this is because the legacy server has Docker installed on it. So it supports Docker currently. So you don't have to move it onto another server and create a whole Docker setup for it unless there is a business use case for it. But as it stands now, there's no business use case for us to go on that provision of a new server just to do that. We are just trying to keep our applications running and also make sure that any application that's run on the legacy server is able to run irrespective of the JDK, JAV, JVM, the API you're coming with or the environment configurations you're coming with. It shouldn't affect our solution. So let's give it a while. When it's ready, we'll come back and start our application. Okay, so uh Docker image has been made available on our legacy server. So we've been able to download the Docker image. So the next thing we want to do is that we want to run our Docker image. So we actually we have our image. So we want to start a container for it. So we'll say Docker run -p. Then we'll just say outside is port maybe 82, inside is port 8082, then codefilms PLC and Dockerized application. All right, so what we're just doing is that we say, hey, we've gotten an image. we came with we came with a solution in the legacy server says, I'm not going to work with you. Now we came back and it says that fine, we've come as Docker. So let's see if legacy server will still work with us. Right, so let's just go ahead and hit the command. And fantastic. You can see that it's actually starting an application for us, which is very fantastic. So what it's actually saying is that legacy server says that, oh, you came with you came with a unsupported version. I said no, but you've come with Docker. I've said yes. So our application actually starts. So let's go ahead and actually run. Let's start this. Let's actually call the API now. So for the avoidance of doubt, let's call the API. So let's call it with Postman. Let's try and start Postman. Yeah. So we're actually seeing the beauty of having it in Docker. Let's allow. We'll wait for it to start. Yeah. So this is just one use case of one use case of the using to Dockerize. The other use case is with the environment variable. So we'll copy the same Docker file here. We just do some reuse. Let's paste it in software as well. And when we go to software, cancel. So when we go to software to still use Java 17, then we are going to still codefilms, but we'll copy the target file we'll copy is not going to be this. It's going to be software and then the version. So we just go software and the version. Then yeah, copy it. Yeah. So copy that to the home part. Yeah, then do the same over here. And because it has an environment variable setup, we'll see um, get an environment variable from VOS. So we just do env, then we say build version. Then we define our build version here. Let's check for one of the notable build versions. Alright, so let's find that from our app. Let's go with 1.3. We've seen home already. Let's go with 1.3. All right, so this is the next one we're going to do. So we've been able to construct our Docker file to be able to prepare our image for us that will run a container on any target environment you choose based on irrespective of any environment variables and interferences that can come from the target environment. It's going to run in its own encapsulation. So we've been able to do that using the Docker file. All right, so let's um let's test our API that we've deployed on our legacy server. So to do that, we're going to just create a new simple request, and let's just fire the request. So say HTTP, then 192.168.223.94. And speaking on port 8082, then we'll go to applications.ws and we're calling greetings. So what we are seeing that we've been able to do our deployment, we'll call 8082. 8082 is the port that um, the legacy server is open to listen to connections for this application or this container. So we've opened a port at 8082 and we are going to call our API inside the application and see if we get a response. So when we send a request, we should get a response from the server. Alright, so let's just wait for a while, then we inspect. So as we wait for that, it's time for us to also build this image, then also deploy it on our server. So how we're able to write these instructions, as we said earlier, this is not a Docker class. We have the Dockerfile reference whereby you can spend some time to check out anything that comes into your mind in regards to anything in regards to Dockerization or writing a Docker file that can build you an image or a virtual operating system. So you can actually find all that on the internet at the Docker API, and that's just the Docker the Docker document, the Docker document, and figure out anything that comes into your mind. So this is not a Docker class. This is just we putting our application containers. Right, so let's see if we have any response from our API. Alright, so good. Interesting enough, we've been able to reach the container, which is right now application, but it says something is not found. So we actually have to go and check our API directory for the solution we sent to the cloud, onto the server, sorry. So we have to call it with API. So let's add the API to it. Then let's go and proceed. So send the request this time around. It's saying not found. Are you doing the right thing? Let's change it again. Let's look at it. So it says API then greetings. So API just before greetings. So we have to do it before greetings. All right. So let's call the API again. Fantastic. So it says we are in continuous deployment mode, then we have a response. So which means that our deployment was successful, which is very good news. So we've been able to do a successful deployment. And if you check the logs for our application, because okay, it's been able to record it's been able to record it's been able to record some activity. Right. So we can actually add some more logs just to be sure that we are actually doing the right thing. So let's just do that. Self-LG4. Let's use one of the logs. And we'll just say log.info. And we say API endpoint called from, let's get a Java version. So system dot get property Java dot version. So system call from let's use the operating system rather. System call from os.name. Yeah. So which means I have to build a new image, then we have to send it over to the cloud. So we'll come back to that. So let's actually now send the environment variable also onto the cloud, the one that keeps our application self-isolated. So we have our Docker file here, and we've been able to write our Docker file to read from our environment. That's a build environment variable we've set inside our Docker application. So let's go ahead and build this and send it over to the cloud as well too. So we'll go to software and we'll do Docker build, read the Docker file, and let's give it. We are building an image for it. So we'll call this um, software um, software container. Then we'll give it alpha. Yep. So let's build this image too as well. Okay, so this image is done. Let's push it to our repository. Alright, so we are sending this also to the cloud, and we are going to get it from the repository. Once we get it from the repository, we'll be able to also call it irrespective of where we set up our our environment variable. So we are okay with this. We are okay with this. So we can actually go ahead and log out from the legacy server because we can actually see that it's working. We've been able to get a response. We started everything. If not for that, for the avoidance of that, let's kill the container. Good. And let's try and call the API again. You realize that it's not going to work. All because the application is down, as you can see. So which means that what we were doing initially was right. Was very, very right. Right, so let's close this now. And let's go to our other server. The server that has an environment variable set up on its target environment, which can easily cause some interruptions. So we'll start our app server, then we'll do a deployment over there. I don't know if I think maybe app server may not have support for Docker. Let's just check. If it doesn't, then we'll have to deploy it on a legacy server again. Then we will test and see if any environment variables that we manipulate can affect the application. Alright, so let's log in. Okay, so let's confirm we have an environment variable here for build versions. So what we did, we'll print all the environment variables, then we'll try to grab build version and see if there's a build version instance here. So there's no build version instance. Okay, let's also check if we have Docker here. And there's no Docker here, so there's no need for us to even be in the server. So let's actually go back to our legacy server and let's actually play on the legacy server. Okay, so we are gradually getting to the end of our course film, and this code film has just generally been re-putting our application in containers. So we've seen how we've done that with the help of creating a Docker file, and we've been able to build images, and we don't even keep the images locally. The images are available in a repository, so our solution becomes universally readily available for deployment. And we've seen how to run our application so that it runs in a container without it being affected, without, first of all, it being, uh, without it being disrupted with the target environments, um, installations or platforms that has been set on it. That's whether it supports a Java version or not. We've looked at that, and we are now also looking at how it promises us of a self-isolated unit, irrespective of how our environment variables are set up on any form of interferences or any form of disturbances that can occur when the environment variables are manipulated. Sorry. So let's check the status of our legacy server, and then we go ahead and run our software container here. Yeah, so Docker is making all this possible. Docker is making all this possible. Sorry, app user. Then app user 2024. And we'll go ahead and let's pull our image in. Yes. So pull our image then. Once we're able to pull our image, we'll be able to confirm Docker on the server. So we'll go ahead and pull our image. So Docker pull codefilms PLC and call software container. We will call this one alpha. So we are calling the alpha instance. We are pulling it from the cloud. That's from our repository. Right. So we've been able to pull it. Then we're going to run this now. So let's check out Docker images. Right, so it doesn't even, so we have software container. So we've been able to pull software container 5 minutes ago. Right, so let's run this and see. So Docker run codefilms PLC software container. It is unable to find. Oh, we didn't give it a tag. Let's call it the tag alpha. Good. So fantastic. So this is license running is professional, which is very interesting. So we can also see that we didn't. So it was created 5 minutes ago. That's when we deployed it to the cloud, and we've been able to call the image, and then the image that we are calling is running professional. So I think if we go back here to 1.3, we set was for professional. Fantastic. So let's check again. Let's look at this. So it's calling 1.3 here. So let's also try and do something to the application. Let's see if we can actually disrupt our application because of the environment variables that we will create. So first things first is let's find out if we even have a build version instance here. No. So let's also print. Let's just see. Maybe we may not be right. So these are all the environment variables here. Okay. On this legacy server. So fine. If that's the case, then let's also create our own variable. Then let's run it. So we're creating our own environment variable. So we'll give it one of the versions that we know. So let's check for student. So let's put student 1.7 and let's run our Docker application again. It doesn't get affected. It doesn't get affected at all. It says license running is professional. But if we bring the original jar here and we come this time around, it's going to blow up because the environment variable is actually active in the on the target environment, which is you can see here. But because Docker is shielding us, Docker is not making us see that it's being affected. So if we decide to just now go with the normal deployment and say, yeah, we get it. That's what you're trying to say. Let's prove it. Fine. Docker is saying that it's not going to work. So we have the jar here. So this is the server. Okay, we already have the jar here. So we've done the deployment already. Yeah, in one of the earlier we looked at that. So we already have the jar here. Oh, it's not. So it's not in the server now. It had to be the app server. So let's close that connection. Sorry, so many tabs running through my face. And I'm also enjoying it too. So it's actually a change in the server. Remove too many servers here. So let's put the application here. Okay, so it's now on this server, even though it's the same IP address. Sorry about that. And let's run what Docker is saying. No, let's just check 1.7. So 1.7 is supposed to give us students. We've checked that already and we are sure about that. So we'll go ahead and say java.jar and software. Okay, so we have an issue. So this is running the class part issue. So wow, fantastic. So because we've dockerized it, because we have dockerized it, we are not actually seeing this issue. Wow. So let's actually go to the server that supports that. That's the 1.8, the Java 17 server. The beauty of Docker manifesting itself. Alright, so let's go. So let's go ahead and run that server. So we are just going to do that. We are going to see how interfering with the environment variables is actually going to affect our application. You've seen out here that it's not working at all. It's still running professional, irrespective of the environment variable that's been set. That's 1.7. And even if I go ahead and if I go ahead and cause a change to it, 1.6, like grep it, you realize that it's still not going to work because Docker has containerized it for us, still running professional. So let's just go out of this server and then let's go and run it on the server that supports it. Alright guys, so when that server starts, we'll actually just come and then we'll check the environment variables, then we call it a wrap for this codefilm. So let's just come back in some few seconds. Alright guys, so our server is up now. So what we just doing is run the login and we want to interfere with the software that we built. We want to just interfere with its environment variables. Let's just mess it up. So actually let's actually do a new deployment. That's much more better. Let's do a new deployment. So we actually see that we've done a new deployment. So we're going to do a new deployment without Docker. So we just do a moving build and moving queue. And moving package. Alright, so let's remove the old jar. Okay, and let's do a new deployment here. Do this. Um, Let's, let's connect it again. I don't want to. Yeah. They don't want there to be probably issues of old sessions. Let's just start the whole thing again. So let's connect to that IP address. The IP address, fortunately, may not have changed. Let's click connect and see. I think it's skipping us, so we have to check the IP address. So let's just check the IP address. It's 94. So at 94. Yeah, so let's fix that. Yes, I have had it updated. Okay, so we're ready to deploy software onto the server. Since there's an issue again, could not connect to server. Let's try again. Authentication failed. Let's check again. Alright, so we're finally in. Now let's deploy. So let's go and get the jar file from our local environment and send it over. Software. Target. Copy and drag it here. So we're actually doing a deployment. Then we run this again. So we go and check our files. It's showing software. We can see it. Then we try and run it. We running it without we ran it without the environment variable throws an exception. And once we create the environment variable, realize that because it's actually running without a container and it's actually eh, interacting directly, or is the right way down says it's being infested by the target environment. You're actually seeing exceptions here. So once you go ahead and create this and run it again, it says professional, which means that the software that we built has it has a dependency on the target environment variables and any configurations or parameters that can be set up with it, which we wouldn't like in our case because anything can happen and our application can misbehave or behave in any way that we are not expecting it to be. So you can see that the license that is running is changing. Like when we had the Docker instance, this wasn't the case because the Docker instance does not permit us to do that because the Docker is running its own isolation. Alright guys, so this is it for this codefilm in regards to putting application in containers. The next codefilm after this is going to be a synergy between two technologies. That is Docker and CI/CD. That's how do we move applications easily from local or from our local host to any server without going too much stress. We've looked at Jenkins already for automation and continuous integration deployment. And the reason we are calling this is because we realize that we've added some logs here. And I'm not really willing to go ahead and write the commands to build this and compile it and package it and send it all over to the Docker hub. It's a lot of work because I have to actually do a Maven compile, Maven package to just get this thing into the cloud. But if I can do a synergy between Docker and Jenkins, which means that I will not have any issue. Jenkins naturally handles all the deployment automation I need to do for any update I do. Then one Jenkins handles that Docker just runs the application in a container. So that's what we want to look at in our next school film. We want to look at how we do Docker and Jenkins so that Jenkins handles the automation process of you writing all these Maven clean, Maven compile, and moving the application, moving the jar files to the server. Maven can handle all, Jenkins can handle all that for us. All we just need to do is we just need to have our pipeline set up. Then once our pipeline is set up, we can actually do our deployment. So we will look at that synergy and we'll look at how we're going to make that possible. So as it stands now, everything is working perfectly the way we expected it to work with regards to containers. So we no longer want to be typing down Maven commands anymore. We want Jenkins to handle that for us and also help us with our deployment and even speaking to our Docker repository, because once we clean and build and we build a Docker image, to get it on the server, there has to be a mechanism whereby there's the Docker on that server gets the latest images. We don't run old images on the server. So we got into that cool film, and it's possible because we've been doing Maven clean, Maven package, Maven clean, Maven package, and we realized there's a lot of stress, and we've also been pushing to the cloud. So if Jenkins can help us with that, all that automation and all that we do is that we just rely on our Jenkins pipeline to do that. We do a simple git push. Jenkins build everything and then it does everything for us because it's automation, we are automating it. So we'll look at that in another code film and expect more code films from us. So we've looked at a lot of things today in regards to Docker and containers, and I've really enjoyed this session because it has helped me to appreciate Docker very well. So this is Cool Films as usual. We share technical solutions and we provide technical solutions to as well. So we share and provide technical solutions. So I'll see you in another cool film. Don't go anywhere and then see you guys later. Bye.